All right, 6.5. There's two special cases of factoring that we're going to do for this one. The first thing is it's perfect square trinomials. And the big thing on this one is if it's trinomials, this is 3 terms. This one has a shortcut if it's a perfect square trinomial. Now, here's what makes something a perfect square trinomial. It's still quadratics. Still going through this part of it. What makes perfect square trinomials is that the a term, all right, one second, back up here. We're doing ax squared plus bx plus c. What makes this perfect square is that the a term is a perfect square. And that the c term is a perfect square. Yeah, so if in the perfect square meaning it's 3 times 3, it's 4 times 4, it's 5 times 5. It's one of those numbers that you're going to take some number and multiply by itself. So, if you go through your perfect square numbers, that's going to be 4, 9, 16, 25, 36, 49. Any number that you would just do some number times itself. So if you see those numbers on the first and last terms, then that's when the button should be clicking in your head going, hey, I think there's a shortcut here that we can do for this thing. Okay, now, and here's the actual technical check to know with this one, is that if b is equal to 2 times the square root of a and the square root of c, then it's a perfect square. Okay, so if you square root a, square root c, get those two numbers, and you multiply that times 2, if the b term equals that number, then this thing has a shortcut, and we don't have to go through all the steps of doing the a times the c and the factoring and all those things. If that comes out to be the case, then all you're going to do, if you had this thing, it's basically going to be this. It's going to be the square root of a x plus the square root of c squared. Now, and if you want, basically here's, let me back up one step. Because here's technically what you would do. That you would write it twice. But because you write it twice, then you can say, all right, well, that's just the square root of ax plus the square root of c squared. Now, and I know this looks funny because you may go, okay, you're losing. There's too much stuff in there. Because when we actually do the square roots, it comes out to be that it's 2 and 3 and 4 and 5. So it looks a lot better than this because I realize that doesn't look very pretty at all. So let me give you some problems here, let you kind of see, exactly what this will look like with some actual real numbers here. Okay, so in 6.5, this will be objective number 1 that we're going to do. And again, we'll go through some different examples here, so we'll call this 1A. Let's give you y squared plus 10y plus 25. Now, somebody may be saying, well, that looks just like the factoring that we did before. It is. But again, they're wanting you to see on this one that they're going to tell you to factor the perfect square trinomial with, so they'll tell you it's a perfect square trinomial. So they're going ahead and kind of tell you that this thing's perfect, so there's a shortcut to this thing, because it is perfect. Square root of 1 would basically be 1 in this case. Square root of 25 is 5. So that's our c term. And now, a term is 1, so again, if you square root 1, it's still 1, so that part's okay. But those are both perfect square roots. And if you do 2 times 1 times 5, that does equal 10, and that's the b term that we get here. Okay, so here's what they're saying. All right, if that does check out, if those two things work out to be the case, then the shortcut is, basically, we're going to do the square root of 1, which is still just 1. That's 1y plus this 5. Technically, we'd write it twice. If you were going to go back and do the full method and go through it, it would be this. But instead of having to do all that, it says, all right, shortcut is, let's just do it as, we don't need a 1 with the y. We can just do y plus 5, and then make it squared. And somebody may be going, well, that's not really any shorter than if we were going to do it the normal way. Okay, it's not, but let's give you one where it actually would be. This would be the second part of, I guess, objective 2 here. Because this is when it really kicks in, where you actually would make more sense, that you get something like this. 9x squared plus 48x plus 64. This is when it actually would make sense. The first problem you may go, well, no, I don't want to do that. That's too much work to get an answer that I already know what the answer is. Okay, here's where it comes in. Because if you do this one, like we were doing in 6.5, you've got to do 9 times 64. Anybody know that right off the top of your head? Not stop and think? You got to stop and think, right? Yeah, you got to go 64, 36. That's 500. Whoa, that's 576. You serious? No, I don't want you to do that. Because you don't want to have to start breaking down 576. If you get a huge number, that's when the warning bells should be going off of going, okay, perfect square. So this is saying, all right, you don't have to do this. Because 9 is, if you square root 9, that's 3. If you square root 64, that's 8. Okay, and then again, the only real check to this one is that if you do 2 times 3 times 8, does that equal 48? 2 times 3 is 6. 6 times 8 is 48. So that does equal 48. Okay, now, the good news is when y'all do the homework, if it talks about a perfect square trinomial, you really, I didn't see any of these that were prime. So they should all check out for this thing. So here's the shortcut. If this is 9x squared, basically this is going to be 3x times 3x. If this is 64, that would be 8 times 8. So that's all right. Well, then you're going to do 3x plus 8 and 3x plus 8. But since you repeat it twice, the answer is just going to be 3x plus 8 squared. Because if you didn't do the shortcut, you're still listing the factors of 576, and you're going, wow. You know, you're still writing those down. So whenever you see them talk about perfect square trinomial, there's a shortcut in this one. And again, it didn't really show up here because you're like, well, the numbers aren't that big. If I'm getting 125, or if I'm factoring 25, it's either 1 and 25 or it's 5 and 5. And you're like, well, it's got to be 5 and 5. You know, so that one, it may not be much of a shortcut. This one, it's a huge shortcut because, again, you don't want to start breaking down 576 and going through all the factors because it's just going to take a long time to get there. Okay, let's do another one of them. Okay, so for this one, let's go with 4x squared minus 28x plus 49. Okay, and again, the big hint on this one is that when you do these problems, it tells you factor the perfect square trinomial. So they're already giving you that hint that, okay, I'm going to this thing, it's going to be a perfect square trinomial. And basically it's this, when they give you that hint in the homework and in the problems and whatever problem you're doing, if you take 4 and square root it, that would be 2. So this is going to be 2x and 2x. If you square it to 49, that would be 7. We're going to put a 7 here and a 7 here. Okay, and with the perfect square trinomials, as long as it's perfect square, if they tell you that this sign is a minus, that means that both of these signs in the middle have to be a minus. So it'd be 2x minus 7 squared. Let's give you another one of those, just to make sure we got it. Go with some really big numbers here. Let's go with 36x squared plus, that's the last number, 81. Be 108. Okay, and again, you don't want to do 36 times 81 because too big of numbers. But again, it should be that this is a perfect square. So if you square it 36, that would be 6. If you square it 81, that would be 9. So this would be 6x times 6x. And then with 9, put the 9 here and here. And again, whatever the middle sign is, basically it is that it has to be the same. So when you pull it all together, we'll do 6x plus 9 squared. Okay, now honestly on that one, that was picking the two, because this the one off the top of my head as we're going through these. Should have changed one of these numbers, because if you get to the end on this, both of these are divisible by 3. You know, you may go, well, what about, so that was probably a bad number. I should have picked it where this would have been more like 6x plus 5, because in this part with the perfect square trinomials, they didn't have any that I could see where you would have something to factor off. So for this one, we'll leave it like that, but you know, technically we were supposed to go one more step with that one, but we're going to leave it this way because I picked back numbers. Because I just made this one up just to kind of get us one more there. Okay, so if it's perfect square trinomials, there's a shortcut. This number is going to be a perfect square, this number is a perfect square, and basically this number goes first twice. This is your second number twice, and because it's the same two things 2 times in a row, just write the one expression and put it to the squared power. Okay, so that's the first shortcut. Perfect square trinomials. And again, they'll give you some easy ones that, with the easy ones, it's almost a waste of time because they're so short anyway. If you don't do it, that's fine. It's the bigger numbers when you start doing the A times C method and you go, wait, that's too big. That's really where this thing comes in. When the first number is something other than 1, it makes this a lot more effective when you go through and start factoring this. Okay, and then the second thing that they're going to do in 6.5. is the difference of squares. Okay, and the big thing with this one is, when they talk about everything on this one, the real big difference between the perfect square trinomials and this one is that with the difference of squares, this one only has 2 terms. And if you look at, 2 terms here, again, you've only got 2 options. It's either got a greatest common factor or it's going to be the shortcut. There's no other thing you can do with 2 terms. That's why with the 2 terms and 4 terms, there's only one option here. You know, there's a couple of small options. With the 3 terms, there was more stuff here because that was what we did back over here just a second ago with the A term not equal to 1. But with 2 terms, it's either a greatest common factor or it's the perfect squares. And again, they tell you on this one that you get a heads up. It's going to tell you to factor using a difference of squares. So that, again, kind of already seen that one. So this one's going to be this is objective number 1, so we'll do 2 or 3 here. It's basically going to look like this: x squared minus 9. Now, there, and again, here's where it's still the difference of, and they kind of leave one word out. If they say it's the difference of perfect squares, then that's really kind of what we're looking at this thing. They just say it's the difference of squares, but technically it's the difference of perfect squares. Okay, now it's kind of almost the same things. That you've got 1x squared and you've got 9. If you took the square root of 1, that would be 1. If you take the square root of 9, that would be 3. It's the same setup. The only difference is if it's two terms, you would still do 1x and 3. You would still do 1x and another 3. The only difference is if this is a minus 9, one's a positive, one's a negative. So it's y squared minus 16. Well, y squared is y times y. 16 is 4 times 4. If that's the only two numbers, then we're just going to do, the answer is going to be y plus 4 and y minus 4. And somebody's going, well, there's got to be more to it than that. No, this one is just that quick on the answers. There's no anything weird. It's just the numbers are perfect. The only thing that they could do that might be the least little bit tricky is they might reverse the order, put the term with the variable last. Well, since the 36 was first, we'll put 6 and 6 first. Since the z was last, we'll put the z last. And then you put a plus or minus. Oh, sorry, this is not objective 1, this is objective 3 back here. My bad. We're still in 6.5 Spark, so sorry about that. Okay, objective 4, it's the same concept. They just start throwing different things at you that they just make the first, instead of the first number always being, instead of the x or the variable always just having 1 as a coefficient, on these they just change it up where, okay, now we're going to have it so that the number with the variable is not 1 anymore. Now it's going to be another perfect square. It's going to be 4, 16, in this case 49. Still going to work out the same way though. Because 49 would be 7 times 7. 25 is 5 times 5. And again, one needs to be a minus and one needs to be a plus. So, and again, to me, the big thing is on this one is, especially when you start factoring and it just, you know, it's going to throw you problems all over the place. Have this thing out with you. If it's two terms, you only got one option or two options. There's either only just the greatest common factor, or you've got the shortcut for difference of perfect squares. You know, if it's 3 terms, you're back here to look at this one. And if it's 4 terms, again, there's really only one of two things it can be. It's either just the greatest common factor, which it's probably not going to be, or it's factored by grouping, which is what's going to be in most cases. So if you have this out, it comes in handy just so you can, because most people do good with one or the other, but when it just starts throwing them at you in random rapid fire, it's knowing, okay, what do I do? And that way you can at least look at it and see exactly what you've got to do here. Okay, so let's go 36 minus 121x squared. Okay, 36, again, perfect square, so that's going to make it 6 times 6. 121 is 11. That one's got the x, we'll put the x there. And again, one's a plus and one's a minus. So those are really straightforward. There's no trick parts so that you don't have to check anything because it's the same thing as the other one. Again, the only difference is if it's a perfect square trinomial, the signs are the same. If it's a difference of two perfect squares, then the signs have to be different so that you do get a negative number there. Okay, and then the last objective that they give to you. Still doing perfect squares, so it's still on the same line, but they kind of take this one an extra part of it. The biggest thing they're going to ask you to do on this one is you're still going to factor. Or they're going to tell you the fact of the difference of squares. Involving the greatest common factor. So they're telling you, all right, it's two things. We are going to have a difference of squares, but you're also going to have to do the greatest common factor first before you can get there. Okay, now, they'll give it to you on these because they're so short. When I had the one before, again, I should have picked a different number just to make it work out. But these, it should go pretty quick. And now, a lot of people may look at this and go, well, 4 is a perfect square, 36 is a perfect square, which they are. But again, if you go back to this one and kind of look at it, first thing you always want to do, and again, they're kind of tell you that you're looking for a greatest common factor. So if you get that one, they're telling you heads up, okay, you've got something you've got to divide out of this. 4 and 36, you can divide both of those by 4. So go ahead and divide them both by 4 first. So now you've got 4, and then you have w squared minus 9. And now this part is another perfect square, but we're taking out the greatest common factor. So w would be, or w squared would be w times w. The negative 9 would be a positive 3 and a negative 3. Okay, this one I think will actually be a little bit better. So let's go with 20 minus 45z squared. Okay, now they're not perfect squares, and this is the one to me that's a little bit better example of it, because on this one, 20 and 45, they're not perfect squares. So then again, if they're not perfect squares, back to the list here, you've got to take out a greatest common factor. Well, you can divide them both by 5. So if you divide them both by 5, that leaves with 4 minus 9z squared. And once you take the 5 out, 4 is a perfect square, 9 is a perfect square. So that leaves you with 2 plus 3z and 2 minus 3z. Okay. And then the last couple problems kind of mixing in. They go one more step with this one, is that besides the greatest common factor just being a number, it might have a variable in it too. Because you have 4 and 64. You can divide them both by 2, but really you can divide them both by 4, so we can definitely take out a greatest common factor of 4. Since this is y to the 4th and y squared, you always take out the small amount of y's, which would be y squared. So 4 divided by 4 is 1. Y fourth divided by y squared would leave you with 2y's for y squared. 64 divided by 4 is 16. When you take out the 2y's, then the y's are gone, and you're left with y squared minus 16. Okay, so y squared would be y times y. 16 again is a perfect square number, so we're doing 4 times 4. Again, 1's just a positive, and 1 would be a negative. Okay, and one more, and we'll wrap this part of it. (48w minus 75w to the third). Okay, and again, neither one of them are perfect squares as they are. 48 and 75, you just have to figure out what you can divide into both of those. And if you start going back and listing again, this one's even, this one's odd, so you know that 2's and 4's and 6's are out. Because if it's one's even, one's odd, it can only be an odd number that you can divide into it. If you start going back and checking, 1 and 75, you get 75. The only other ways that you can get it would be 3 times 25 or 5 times 15. The only number that goes into 48 is 3. So for this one, the greatest common factor is going to be 3. This one has w to the first and w to the third. So again, you can take out the smaller amount of w's. So basically just take out 1 w from each one. 48 divided by 3 is 16. We took the w out of this one. 75 divided by 3 is 25. If you take 1 out, you're left with 2. Okay, 16 is 4 times 4. 25 is 5 times 5. Again, 1 to plus, 1 to minus. And then that's the final answer we're looking for. Okay, and that's the last of 6.5. Now, and I'm going to go ahead and do 6.6 in with 6.5 because there's only one objective in 6.6, and it's one of those objectives where it's just, here's a formula, you take these numbers, you plug it in the formula, and that's it. There's nothing else you can do with it. Honestly, it's one of those problems where you'll see this part of it once, and you, depending on how far you go in math, you may not ever see this one again. Just depending on, you know, exactly what you do with it here. Okay. And this one's not even on your factoring sheet because it's just one of those oddball things that if you want to put it on there, you can, but it will tell you, find the sum or find the difference of these two cube numbers. It's honestly, it's one of those things where, again, it's a specialized factoring thing, and you only use it once every blue moon for what you want to do. Okay. So here's what we have. You have basically the difference formula. Okay, and basically it's this. It's x cubed minus y cubed. And we'll kind of give you this is the formula that you would do, and we'll go back and plug the numbers in on it here in just a second. And basically it's this. We're going to take, if it's x cubed minus y cubed, it's going to be just x minus y. We've got x squared, so if we do x times x squared, we'll get the x to the third for this part. And we're going to have plus xy and then plus y squared. Okay. And all we're going to do is we're going to take the numbers we have and the values we get, we're going to plug it in this formula, and then that's it. You don't do anything with it. It's just, I'm going to take this, I'm going to plug it into the formula, and then that's my answer. And there's nothing you can do with it. Which is kind of weird, because all the other stuff, you know, we've got this little steps we do, and we do this, and we get to the end, and it's all nice and neat. It's a nice little package. This one, it's like, okay, I take this, and I plug it in here, and then that's it. That's all you do. Okay, for the sum of two cubes. Same thing, but now instead of being x to the third minus y to the third, it's x to the third plus y to the third. Okay, and it's the exact same formula. The only thing that you do different is that you're going to change, you're basically going to swap where these two signs go down here. So this one's going to be x plus y, this one becomes x squared minus xy. So there's not a huge difference in which one you do and the way the formulas are. The only difference is, again, if this one's minus, the first number is minus. If this is a plus, the first one's a plus. And then the first two are alternate. The last term is always a positive. All right, here we go. So we'll give you 2 or 3 examples so you can see what it is that you have to do. And again, it's not one of those that you're going to use a lot. You know, it's a special tool that you're going to use if you're working on the car. It's a I remember one time I was having to replace a oxygen sensor, and to get to it, you had to have a special wrench that was L-shaped, but it had to have a notch in the end of it so you could slide it up and over, and then you had to twist it and then take it off and twist it because there was no way to get around the wire to get to it, and you couldn't use a regular wrench because it had to come in at an angle, so you had to go buy or borrow a special wrench that you would use once every 10 or 15 years on the car, if you had it that long. It'd be like having a melon baller. How many times do you make fancy, take melons and decorative stuff? You just don't, right? Unless you're a decorator, you're a caterer or something, then you use it all the time, right? It's just one of those little special things, like the attachment that you get on your vacuum that looks like a walrus, with the, what is that for? I don't know. Cat hair? Okay, maybe. Is that what it is? Okay. Yeah, I don't have cats, so okay, so here's all you have to do. We know this is x, so everything in the formula up here is going to be this one. So we're going to go back to the formula up here for this part. All you've got to figure out is, all right, if I'm doing x cubed minus 8, that really means this would be x cubed. And you just have to figure out, all right, what number would this be cubed? 2 times 2 is 4, 4 times 2 is 8. So 8 is really the same thing as 2 cubed. So all we're going to do is we're going to take x for x, which is going to be the same thing here. But everywhere we have a y, we're going to replace it with 2. Okay, so if we do this part, here's the answer. It's going to be x minus, again, everywhere we have a y, we're going to replace it with 2. So this is going to be x minus 2. Then it's x squared plus x times 2 plus 2 squared. So that's x minus 2. That's x squared. And then we'll reverse this around so it looks like what we normally do, 2x. If you do 2 squared, that's 4. And that is your answer. And you may go, well, that looks 10 times worse than what we started with. It is. But again, if you're moving on somewhere down the road, there'll be a problem that you'll do one time that this will help you solve, and then you get some stuff. You go from there. Again, this is one you just put in your back pocket. If you get it, that's great. If not, it's fine. It's one of those problems that it shouldn't pop up on the test because, well, it might have to give you 1 just to say that we tested you on it. But that's it. It's just that 1. If you get it, that's great. If you don't, you still make it 96. Yeah, just let it pops up here. All right, let's give you one more here. Make one with a plus. Let's do 125 plus 27w to the third. Okay, and again, it's got to be that we've got something to the third power and something to the third power. 125, if you check it, that's 5 to the third. 27 would be 3, but we do have the w, so that's basically 3w to the third. Okay, and then the cube formula was basically this. Just so we don't have to keep scrolling back up and down. Okay, now we don't have x's and y's on this one, so basically here's what we do. Everywhere that we would have an x, we're going to replace that with a 5. Everywhere we had a y, we're going to replace that with 3w. So this is going to be 5 plus 3w. That's going to equal, again, x is 5, so that's 5 plus 3w times 5 minus 5 times 3w plus 3w squared. Now, and this one gets a little bit more because the numbers are a little bit bigger. If it's just 1 and some number, it goes pretty fast. Where this one's got all the extra numbers in here, it's going to make it out to be, a little bit bigger for this thing. Oh, and they should have been cubed back here. Sorry about that. Okay, first parentheses. There's nothing you can do with it. It's just 5 plus 3w. And that was supposed to be a squared right there. My bad. Left that square number off. Okay, so this one is 5 squared. That we can make 25. This is 5 times 3, so that's 15w. And this is 3w squared, so if you do 3 times 3, that's 9. And you make it w squared. And that would be your final answer. And again, most people go, but yeah, that's way worse than what we started with. It is, but, that's what it's going to be.